So a quick little reminder video about negative exponents, even though I touched on it in the last video regarding properties of exponents. So negative exponents represent reciprocals, not negative numbers, but reciprocals or fractions. And pretty much anytime that we're going to evaluate, we only want to leave positive exponents. Basically, the only time you're ever going to leave a negative exponent is if you're dealing with scientific notation, which we'll see in our next video. So we're evaluating. Remember, evaluate basically means to simplify. So we just want to simplify as much as possible here, and sometimes a calculator is going to be handy. So we can rewrite every negative exponent in terms of a positive exponent. So remember, 5 to the negative 2 is really over 1. And whatever has a negative exponent is going to flip to the bottom. So 5 to the negative 2 is the same as 1 over 5 to the positive 2, which is 1 over 25. Let's keep going. Here we have the quantity negative 3 to the negative third power. Now I'm going to keep that negative 3 nice and snugly and warm inside of those parentheses. The only thing that's going to change here is that negative exponent. It flips to the bottom and becomes positive. So we have 1 over negative 3 times negative 3 times negative 3, which is negative 27. 1 over negative 27. Now, this next one is very special, and this is one of the problems that separates math men from math boys on standardized tests. This does not have parentheses. So if it does not have parentheses, it's kind of like it's exactly like negative 1 times 3 to the negative 2. We could also read this as the opposite of 3 to the negative 2. So because of order of operations, if there are no parentheses, this will stay negative. So negative 1 times 1 over 3 squared. Negative 1 over 1 times 1/9. So that is negative 1/9. The opposite of a positive number is a negative number. So because there are no parentheses, this will stay negative. Next, 3, x to the negative 6th, y to the 4th, z to the negative 7th. I'm going to put all of this over 1, and I will remind you of this in class. I like to go through and circle each base that has a negative exponent. Remember, 3 has a positive 1 for its exponent. That negative 6 is only affecting the x. So if it has a positive exponent, it stays. If it has a negative exponent, it reciprocates. And then that exponent becomes positive. So evaluate, leaving only positive exponents. We did that. A couple more. Simplify, leave only positive exponents. I purposely used evaluate first and simplify second. Basically, they mean the same things. Sometimes when you see evaluate, you may also have to make a substitution. But basically, evaluate and simplify mean the same thing. So, these two problems a little bit more involved. We need to follow order of operations, and because of order of operations, if we first look at the first set of parentheses, nothing to do inside, but that second set of parentheses has that exponent that's outside, and that needs to be dealt with first. Now think of all of this as over 1, so that means we can take this whole quantity and reciprocate it to the bottom. So we'll be left with negative 7xy to the 4th over negative 2x to the negative 5th y squared. When we reciprocate the quantity to the bottom, the exponents and everything inside the parenthesis stays the same. All we did was alleviate that negative exponent and make it positive. So from here, and I normally work down, but I know I'm going to run out of space, so I'm going to use this right here. The numerator is going to stay exactly the same, and really we don't need the parentheses anymore. To the denominator, this is a power being raised to a higher power, so everything inside is about to be squared. So negative 2 squared, that's negative 2 times negative 2, that's 4. X to the negative 5th squared, power to power, multiply. Y squared. Now we just need to follow the properties for exponents and we need to simplify. So we can start first with negative 7/4. That just stays negative 7/4. But now we've got this x to the negative 10th. It has a negative power, so we need to reciprocate it back up to the top. And there's one power of x that's already on the top. So it's already there, and we're going to put that x to the 10th right beside it. And then y to the 4th over y squared. This is a quotient that needs to be simplified. The bases are the same. There are 4 powers on the top, 2 powers on the bottom. Both of those cancel with 2 of those. 4 minus 2 leaves 2. So y squared up on the top. Only thing left on the bottom is the coefficient 4. So what's left here? Simplify this product rule. Bases are the same. Add the exponents. So negative 7x to the 1 plus 10, 11 y squared over 4. Last problem. The quantity is being raised to the negative 2 power. So in order for us to follow order of operations, actually we could work inside, but anytime there's an exponent that's negative outside, I prefer to get rid of it first. It just saves a little heartache later. So in order to get rid of that negative exponent, we need to reciprocate this quantity. We got to flip the whole thing. So 6x y to the negative 3rd over 4x to the negative 3rd y to the 5th. Now it's all to the positive 2 power. So we flip this fraction and now our exponent outside is positive. So we can deal with this exponent or we can simplify inside. I think I'm going to simplify inside first. So easiest thing right away is the 6 and the 4. 6/4 is 3/2. No big whoop, that's done. Now look at the x's. This is x to the 1st over x to the negative 3rd. This is a quotient. The bases are the same. We can subtract the exponents. So we're going to have 1 minus negative 3. Say it out loud again. 1 minus negative 3 is the same as 1 plus 3, which is 4. So we got x to the 4th on the top. Now, think about this next one. Y to the negative 3rd over y to the 5th. If we subtract, we get y to the negative 3rd, and that's going to be negative 3 minus 5, which would be negative 8. Do we want to end up with a negative 8? I would rather not do that. It would make the most sense to me to let's go ahead and deal with that negative exponent by flipping that y to the bottom. And when we flip that y to the bottom, it becomes y to the positive 3rd, which means there will be 8 powers of y on the bottom. Which, if with that negative 8 were on the top, it would just flip to the bottom anyway. And now that we've simplified the fraction inside the parentheses, we can now raise everything to that second power. So 3 squared is 9. X to the 4th squared is x to the 8th. 2 squared is 4. Y to the 8th squared is y to the 16th. And we're done.